By the end of the lesson, I will be able to classify with justification and graph rational and irrational numbers. Vocabulary. The first vocabulary word is a rational number, a number that can be written as a fraction or a ratio, hence rational number. Types of rational numbers: decimals that terminate, decimals that repeat, integers, improper fractions, mixed numbers. An irrational number is a number that cannot be written as a fraction or a ratio. Types of rational numbers: any decimal that goes on forever and doesn't repeat. Terminating and repeating decimals. A terminating decimal is a decimal that does not go on forever and it ends, so like 0.4 or 0.75. Repeating decimal, a decimal that goes on forever with a number pattern. And lastly, relatively prime fraction is a fraction where the numerator and the denominator have no common factors other than 1. So essentially, the fraction is in its simplest form. When to change a fraction into a decimal. The first thing that you're going to change a fraction into a decimal for is when you need to order rational numbers. The second thing is when you need to compare rational numbers. And the third one is when you need to classify square roots. So are the following numbers rational or irrational, and how do you know? So the square root of 56, I cannot tell if that number or that square root is rational or irrational until I square root 56 with my calculator. So I'm going to use this button right here, which is the square root of 56, and I'm going to hit equals. Notice that the decimal goes for a really long time and it fills up my calculator space. So my decimal is 7.48331477,355. With that number, I can tell that that number is irrational because I can assume that that decimal is going to continue to go on and on and on and on forever to the right without a pattern. There is no mathematical sequence pattern with the 0.4833147735. So that number is going to be irrational. So the square root of 56 is irrational because the decimal goes on forever without a pattern. Now 4.13 and 13 is repeating. So I don't have to change the number, but I can say that this number is rational. And I can say that it's rational because it's a terminating decimal. The decimal ends. It doesn't go on forever and ever and ever. So what you should have written as your answer is rational because it is a terminating decimal, or it ends. Now, 15 divided by 0. We can never, ever, ever have a 0 in the denominator. And if I typed in 15 divided by 0 into my calculator, what happens is infinity, or your calculator is going to give an error code. So if it says error, then I know that it is irrational because it can't be written as a fraction. So in this case, it's going to be irrational because the denominator is 0. And 1/3 I do not have to change because a rational number is a number that can be written as a fraction. So it already is a fraction. So I know that it's rational because it is a fraction. I have a decimal that goes on and on and on forever and doesn't repeat. These 3 dots right here mean that the decimal continues. So I know that a decimal that goes on and on and on forever that does not have a pattern or does not repeat is irrational. .3 is a rational number, and the reason it is rational is because it's a repeating decimal. 5.9 is a rational number because it is a terminating decimal, or the decimal ends. The square root of negative 83 needs to be entered into the calculator. So I'm going to type in the square root of negative 83. And what happens is I get an error because I cannot have a negative underneath my square root. So I know that the square root of negative 83 is irrational because of the negative under the square root. If I take the square root of 6 in my calculator, I'm going to get 2.4494897443, and it fills up my entire calculator, so I'm going to assume that it continues. So the reason that this is irrational is because it's a non-terminating decimal. And what non-terminating means is that it goes on and on and on and on forever without a math pattern. 5 3/7 is a mixed number. I need to be able to write it as a fraction. So I'm going to multiply these two and then add this one. So multiply and then add. So 5 times 7 is going to give me 35. Plus the 3 in the numerator, which is 38 over 7. And because I can write this as a fraction, it's going to be rational. The square root of 9. If I take the square root of 9 in my calculator, I get 3. The square root just means what times itself can get me to that number. So 3 times 3 would give me 9. It is a terminating decimal if you want to think of it that way. It's also a whole number. It's an integer. It also can be written as a fraction. So this number also is rational. Negative 6 is an integer, so it's rational. It's a terminating decimal. It also can be written as a fraction. Negative 6 over 1. 1.76 is rational as well because it's a terminating decimal. It ends. 0.005 is rational because it ends. It's a terminating decimal. So what can we say? The only thing that makes a irrational number is if the decimal goes on and on and on forever without a pattern. Everything else is a rational number. So if the number goes on and on and on and on forever without a pattern, then it's going to be irrational. Everything else, every other number that you know, is going to be rational. So if you keep that in mind, you will be able to steer through those questions a little easier.